Hello all. We, the students of IIITH, will be presenting a demo on the application that we have created for query expansion. First of all, we need to discuss what is query expansion and why it is needed. Query expansion is a key feature of any search engine. In many cases, it is difficult to understand the user intent, which results in the retrieval of irrelevant documents. Query expansion helps users in formulating queries to a certain extent in order to improve the performance of the system. Different techniques can be used in query expansion, like spell correction, finding and searching with synonyms of input query terms, and augmenting the query with augment terms. Our approach is based on the second and third technique. Problems like query drift, which exist in current systems, can be eliminated with our approach, which uses clustering and n-grams. Our approach has two phases, the online and the offline phase. In the offline phase, we cluster the documents together based upon their similarity and index the clusters. We also label the clusters. In the online phase, we query with the input given by the user to retrieve a set of best clusters and use that for query augmentation. Before going further, here comes a question. Why clustering? Document clustering helps to group similar documents together. The query is expanded using these clusters in order to suggest recommended queries from different contexts or categories. We use k-means clustering algorithm as it best suits high-dimensional data. On the basis of observation, we have decided the number of clusters to be 150. Before clustering, we add synonyms for the top 5% of words in order to allow the user to search with synonyms. The clusters are labeled with set of terms that uniquely distinguishes from other clusters. These tags are the most relevant terms in the cluster. Now we will discuss about the online process. In the online process, we retrieve top n clusters based on the input query, which are used for finding augment terms. There are three basic scenarios in this case. The first scenario is one in which the query can be represented in n-grams. Here, the user intent is clear, so we make use of n-gram model for predicting the next word. In the second scenario, the user intent may not be clear because the query terms are separated with some distance. So, by considering Markov assumption, we restrict our n-gram approach to n-1 grams. We consider bigram of each input word for finding augmented words. Also, we add cluster tags to improve the user objective. In the third scenario, there is no correlation between the input terms. In such cases, n-gram and Markov models are not suitable for finding augment terms. So, we consider tags of clusters for query expansion. The above diagram shows the architecture of the offline phase, which involves clustering and indexing. And this is the architecture of the online phase that has just been explained. There are different tools that we have used in our project. They are shown in the slide. Our dataset comprises of news stories from Telegraph Calcutta. Now, we will run some queries and observe the query expansions. We evaluated our system for finding the improvement in precision and recall values after query expansion. The results are as shown. As we can see, there is a considerable improvement in both precision and recall. Here we have presented our approach for query expansion using clustering and n-gram model. We have also evaluated it by measuring the change in precision and recall and prove that the system is giving good results. The time and memory complexities of our application was measured and it is found suitable for real-time search engine. With this, we have come to the end of our presentation. Thanks for watching.